Alright guys, today we're going to finish up Unit 7 by finishing up the Section 3 notes. We just finished talking about Earth's climate history, changes we've seen in the past, and what kind of changes we're seeing now. So today we're going to talk about possible causes for today's changes that we're seeing. In order to do that, we do need to review what a fossil fuel is. So what's a fossil fuel? I'm sure you know. It's a non-renewable energy resource made from organisms long ago, which is why it's called a fossil fuel. However, does not come from dinosaurs. It is the result of mostly plants, or at least coal is. We've talked about this. Coal is the result of swamps. All those organisms that die and go to the bottom of the swamp and don't decay very fast, they're getting buried, they're getting pressurized and heated up in the Earth's crust, and they eventually make coal, like you'd find in West Virginia. And the oil and natural gas are the result of plankton in the ocean dying. So remember, plankton are those free-floating organisms or tiny organisms, zooplankton or phytoplankton. They're going to die, fall to the bottom of the ocean, and get buried, undergo heat, and we have oil and gas deposits being created over the time. Now, mostly they're phytoplankton because of how old these deposits are. Okay. Now we're going to talk about this because one of our biggest possible causes of leading possible causes is increase in the carbon dioxide in the atmosphere. Now, most scientists agree that this is our leading issue. Carbon dioxide levels in the atmosphere will change naturally throughout the year. We'll see less carbon dioxide in the spring, because that's when we have most of our plant growth happening. So there's a lot of absorption of carbon dioxide going on, and we'll see more carbon dioxide in the winter because, again, we don't have that growth. Now, what's happening today, we have some changes that are not caused by natural variations. These carbon levels have increased by 20% in less than 50 years. Now, we know this because scientist Charles Keeling, who was working in the laboratory, the observation tower in Mauna Loa, Hawaii. Now, this is observation, like as in they do a lot of different scientific research there, but mostly they have they have a big telescope there because Mauna Loa is at the top of the big island of Hawaii, and it has very little human impact coming from it. There's not that many people on Hawaii. So we have less light pollution, especially since there's nothing around Hawaii. We have less air pollution and things like that because it's out in the middle of nowhere. So a lot of scientists use Mauna Loa to get records because it's a very good place to have little human influence. Okay, well, they still take records in Mauna Loa, Hawaii, and this is a graph from your book showing the records that they've taken since 1958, and as you can see, we have a very large increase of carbon dioxide in the air over those past 50 years. And these changes, there's nothing that we've seen in our history that come from these changes. Matter of fact, when we look at ice cores, those ice cores we talked about from the last that go back to, hundreds of thousands of years, we don't see any carbon dioxide levels that can even compare to today's levels. Why? What's happening? Well, today humans are using those fossil fuels very quickly, and that carbon dioxide is being released more than any other greenhouse gas that we have. And as we know, greenhouse gases are going to help trap heat, which we like to a certain extent. That carbon dioxide, even though methane and water are stronger greenhouse gases than carbon dioxide, we see a lot more carbon dioxide being added to the atmosphere than those other things. I know methane is a concern for some people, but this is our biggest, carbon dioxide. Basically, what's happening is this. So here's our carbon cycle we've talked about, right? Organisms are part of that carbon cycle because they're made of carbon, okay? And then they are also part of the cycle because they breathe out carbon dioxide. Both plants and animals breathe out carbon dioxide, but the plants will reabsorb it in their photosynthesis. So this is our short-term cycle. Now, these organisms eventually can die and they'll be buried and create those fossil fuels. That's part of our long-term cycle. The carbon, the oil, the natural gas, the coal, those things are what we call carbon sinks, those rocks, because they're stuck in the crust of the earth and not going to be able to be put back into the atmosphere unless there's something like a volcanic eruption or a large earthquake that exposes it to more erosion, that sort of thing. So they're what we call carbon sink because they're stuck there. Now, with our burning of fossil fuels, this is sort of what's happening. This is what I like to think of. So here we have Lucy and her friend Ethel. I love Lucy from that old TV show. They're working in a chocolate factory and they're supposed to wrap up the chocolates, right? But as you can see, they're having difficulty keeping up with that assembly line. What we're doing with fossil fuels is speeding up that carbon cycle. We're taking carbon out of those sinks, those deposits, and we're putting them back into the atmosphere, and it's faster than the Earth's cycle can handle. It's not up to speed yet. Doesn't know how. So we have basically we don't know, the carbon has nowhere to go. Okay. Now there are some other possible causes, okay, or other influences. First of all, the clearing of forests. We don't have as large of forest ranges as we used to, okay, which is going to be a problem because those trees aren't going to be there to absorb that carbon dioxide. This is one of the concerns with the Amazon rainforest, right? And actually, there's a secondary concern from that because when you're clearing forests, one of the easiest and quickest ways, this is what they're talking about with the Amazon, is the burning of the trees to get them out of the way. So if you're an oil company, you just burn them down and take them out and you don't have anything left. Well, burning the trees means that there's more carbon dioxide in the air because burning releases carbon dioxide, right? So that's another influence. Third influence would be the acidity of the oceans. And this is actually sort of a cause and effect, creating another cause. When the ocean will naturally absorb carbon dioxide from the atmosphere, and this is a diagram from NOAA, the National Oceanic and Atmospheric Administration. So they're looking at the carbon dioxide levels in the water, and basically what's happening is carbon dioxide, when it's absorbed, starts to create actually hydrocarbon acid, and it's going to start to eat away at marine life. So you have problems with coral reefs, becoming too acidic for coral reefs, also too acidic for that phytoplankton. And if we don't have the phytoplankton, if they can't grow, if the environment's not helpful for them, they're not going to be able to absorb that carbon dioxide to grow and create that oxygen for us and take it out of the atmosphere. So that's another possible reason for this. Now, I know there are concerns, and there's some reason for that. So what are people looking at as what happens with this climate change? So one of the biggest things we're looking at is rising sea levels. I know a lot of countries talk about this being one of their largest concerns because not every ecosystem is going to be as sensitive as others. If you remember the intangible zone from that video we watched, they had they were talking about how that area was so well defended that it actually survived several ice ages, right? But some areas aren't. So first of all, if you live along the coast, you're going to be flooded, right? So we talked about Venice flooding in our last video. 8 of the 10 most populated cities on Earth lie along coastal regions, and they're looking at ways of preventing flooding for their area, right? Also, of course, beaches are going to experience erosion, but if you have rising sea levels, that erosion is going to come more quickly, and it's going to go further inland. Speaking of inland, you're also going to see changes in your groundwater because of salinity. Now, salinity is the amount of salt in your water, okay? And basically, if that salt water is flooding the coastal regions, then the coastal aquifers, or the water that's held underground, groundwater there, can actually become more salty, maybe even too salty to drink. The other thing that's going to change with salinity is you're actually going to have less saltier oceans and some more saltier estuaries where the rivers meet the ocean, which is going to affect the freshwater estuaries, or sorry, freshwater fisheries that are just inland, and it's going to make them a little bit more salty, and you're going to have less salty fisheries that are right there in the ocean. So it's going to mess with some income there. Okay. Another thing I know that people have talked about, that you've probably heard about, is more intense hurricanes or more intense typhoons, right? Here's a graph from the EPA showing the record. So we've had some intense hurricanes in the past, but as you can see, they're becoming more frequent and stronger in the past 20 years than they were even 50 years ago. Okay, so that's going to be one thing. Now, with these changes in the ocean, we're also going to see changes in the ocean currents, and then from there we're going to see changes in precipitation. And some areas will get more precipitation, others will get decreased precipitation. So basically, sort of like what we see with an El Nino year, only longer lasting and becoming more intense. Plants and animals are not going to be immune to this. Plants won't be able to live in some of their natural habitats, while others are going to be able to move into other territories. I'm going to go ahead here for a second and then I'll come back. But these are the hardiness zones. So this is from the USDA, the Department of, which falls the ODNR falls under this, but these are the growth zones from 1990. So this shows hardiness. What are the temperatures like? What kind of plants can survive here? We were in a zone 5 ourselves in 1990, which means we have plants that could survive colder temperatures and that sort of thing. We wouldn't be able to plant a poinsettia. Poinsettias, if you go to Mexico, they're growing right outside of people's houses because they can live in that warm tropical place. They won't survive up here in Ohio. But as of 2015, you can see those zones are moving farther north. So that's going to affect, we are now in a zone 6, okay? So we're going to have issues with that. So we've already lost some plants that we used to be able to raise, can't be raised now. All right, so we have changes in expanding, we have plants changing their territory, changing in nesting and migration habits for birds. I know in Hinckley, Ohio, the buzzards coming back each spring is a big thing. Well, they came back earlier the last 3 years. They arrived before they were supposed to. So we've already seen changes in that. Also, animal geographic ranges. We've talked about this with the prowlers, the Prisleys or the growlers, those polar bear and grizzly bears coming together, because grizzly bears have been able to expand their territory farther north. Basically what's going to happen, guys, is we're going to see a lot of loss of biodiversity, or coral reefs, other organisms not going to be able to survive. This also has implications for us as humans. Of course, if our growth zones change, what we can grow is going to change. Our habits for farming are going to change. Also, we're going to see increased drought in some areas. We'll also see people being affected more and more by allergies. It's going to become more intense, or heat-related deaths. So there's going to be some portion to it that can hit a little closer to home for us. What's happening with this then? What do we do to slow this down? Well, there's a couple things that are happening around the world. Countries around the world have got together over the years and tried to find some solutions, okay? I'm calling it a treaty, but it's not necessarily a treaty, but the Kyoto Protocol was an agreement created by the UN. 36 countries signed it, trying to reduce the carbon dioxide emissions of that time. More recently, we have the Paris Agreement, and that this time 126 countries have signed that document, looking at ways to help slow down climate change. What can we do? At this point, the U.S. has backed out of both of these. So right now, I'm not sure what's happening as far as what the U.S. government but I know that we have other plans, other things in happening. Now, conservation groups also we know are planning